Hello, everybody. My name is Arturo Baroncelli. I've been working in robotics and industrial automation since 1985. Title of my speech today is Artificial Intelligence, 3D Sensor, Autonomous Mobile Robots and Additive Manufacturing are enabling industrial robotics to fulfill its promises. Why this title? Let's have a look to it in an historical perspective. Industrial robotics was born in 1961. Since the very first years of development, it seems to be the ultimate solution for every production need requiring flexibility. Given the possibility of reprogramming, reachability of infinite position and decision-making, such as through if instruction, if, then what else? In the 70s and 80s, robots started to be widely utilized in various real industrial applications, but practice soon indicated that a lot of unflexible hardware needed to be applied. For example, a classical robotized cell was and is also very much today composed of grippers, fixtures, conveyors, pallets, fences, special electronics, where the dedicated part is far more important than the robot itself, representing the flexible part. Let's see briefly one by one. Grippers, for example, even for handling application of products of the same class, a specific design is needed. Solutions such as automatic changes partially offset the problem, whilst tentative to create artificial universal hands with several degrees of freedom, in reality led to no real use out of research lab, no use in industry. Vision, okay, it emerged mainly to substitute the need of jigs to fixture, to orientate parts to be handled to the system and 3D system later. The performance and reliability have been continuously improved, and today the technical level, the reliability level is very, very high. In this perspective, so robot gripper and vision system, a meaningful result was reached around year 2000, I would say, where the first application of beam picking were applied. A robot equipped with a 3D vision system was able to pick up objects randomly positioned in a box. The first solution were still applied with one specific gripper for one part time. Nowadays, there is evolution. A new approach is being developed. Why? Because there is artificial intelligence, deep learning. With deep learning techniques, we have application where robots with non-dedicated grippers can pick up different objects randomly placed in a box. The level of flexibility is dramatically increased. The presence of customized hardware is eliminated and basically substituted by modern algorithms and artificial intelligence. So the old hardware can be substituted by algorithms and artificial intelligence. Moreover, if the application is done with a cobot, also the fences can be eliminated, another heavy part of the cell. But there is another technology which can enable industrial robotics to reach further flexibility level. The autonomous mobile robots, the evolution of Agv. One advantage of the Agv AMR is to reduce dedicated hardware such as conveyors and pallets, one of many. In this way, we can have one technique. The traditional one is the parts are brought to the fixed robot. The new one is when we have robots mounted on the Agv, on the AMR, and moved around the shop floor where the parts are. In conclusion, for this part, robotic system may be today composed by robot arms placed on an Agv, moving towards different stations to pick up randomly positioned parts with a non-dedicated gripper through 3D scanners, all driven by artificial intelligence. In such system, customized hardware is limited or absent. This kind of application of flexible robots moving around are particularly suitable in handling and assembly applications, which are 40% of industrial robotic application, and in particular, very important today in the booming field of logistics today. That was handling. If we talk about continuous processes, there is another technology that can be utilized together with industrial robots to create innovative solutions with limited need of spatial hardware. This is additive manufacturing or 3D printing. In fact, a robot can be equipped with a 3D printer for a specific process, plastics, fibers, concrete, metal. Also, in this case, there is the software and algorithmical part, such as CAD, finite element analysis, generative design, CAM, which represent the flexible element of the system and responsible for the unlimited possibility of creating innovative application and components. Okay, we are talking about handling application and process application. These two examples cover a huge number of applications in industry and can be considered a basis of the development of the unicorns, going to the title of the discussion of today. Why? Because robot system integrates several technologies. This is clear. I've mentioned it beforehand. One progress or breakthrough in one of these elements can result in an improvement of the whole system. The combined effect of two or more enhancements would be even more dramatic. So, in this perspective, researchers, spin-off, startups are in the best position to develop such kind of disruptive technologies in robotics. Moreover, there are the system integrators. System integrators can combine all such elements in a complex robot system to solve specific industry needs. Third, final customer, both small and medium enterprise, SME, and large companies. They can translate such innovative robot option into competitive advantage. In my opinion, the best approach here is to set up proof of concept as soon as possible as up. Test them, improve, maybe fail sometime, but rapidly put them into operation and translate them into competitive advantage. I agree. Specularly, we have the dinosaur. A dinosaur attitude based on slow, follower-like, me-too, bureaucratic approach may lead to lack of competitiveness and possibly extinction. Conclusion. Different concurrent technologies are being integrated into industrial robots so as to generate a new breed of robotic systems, really flexible, with limited need of dedicated and unflexible hardware. This was one of the original promises of robotics, which, after more than 50 years of development, is being fulfilled, is being kept. Moreover, the process is creating opportunities to unicorns to evolve and dramatically contribute to technical progress where the limits, I would say, are still difficult to forecast. Thank you.